threading index.
I'll start going faster. Kind of keep the same. And the smell of this, I love it. I don't know why you don't like it. Heck, it's cheaper than aftershave.
Now in some of the other videos, you see me making this Kingway Alignment Tool. This is an invention by Richard King's father for lining up bedways and everything. And years ago, Richard gave me a few of the pieces of this, like the cast iron castings here, and even this shoe he gave me. And so I've been putting it together piece by piece over a while because I needed to work on not so much this, but the 10EE lathe. I'm going to be working on that bed, and I need this to be able to accurately measure that, because that's a really precision machine. So I've got everything done up here. I have to make a little base plate for this ball to fit in. That's pretty simple. I have to take and put the precision level tray up here, and I'm sitting here working on designing that. Now, these are the precision levels, and I mean, these are super precision levels that will mount to this tray I'm making. There's two of them, and basically these are really super precision, and they mount with little screw adapters and things like this that go on a post sticking up out of a plate, and then that way you can level and make everything perfect before you start measuring. Anyway, the plate for that rides on this top beam, and you need to be able to rotate it around that beam, and I've been just kind of designing one that will fit this, and it's somewhat easier to make than casting the whole thing. So what I've come up with is this arrangement. Can y'all see that? And basically it's a T about 5 inches long. One level goes across here, and then one sits here and comes down this way. And this is going to be about 3/8 of an inch aluminum plate that I roughed that out on. And then I need a way to mount it to that beam. So this other little dimension right here is 1.5 inch aluminum cylinder that I bore for that beam. I'll put set screws with a plunger on the side to hold it to the beam, and then I'm going to knock the top of it off here. It's going to be flat on that. Put it in a mill and make it flat, and then the T-plate will bolt to that, and it'll all ride up here so you can adjust it. And then you use the leveling screws to get everything perfectly level. Then you can measure as you're going down the lathe bed. Another part of this machine that you can use is with an indicator. You can hang it off of here and measure thousandths, half thousandths, whatever, as you're going down with that indicator. Now, on the ones you always see, they just had a simple screw clamp that went around here and a piece of metal, kind of like on the old style indicator bases. Here's one that's been hanging on the wall so long it's got spider webs on it. I don't like these anymore since the new kind have come out. But basically this was the arrangement that would mount onto the side of this. Well, I think we can do better. I just happen to have a little bitty Nogi style base that I bought years ago by mistake. On eBay, I thought, hey, that's a really good price. I didn't know it was only 6 inches long. Comes with a little base here. I got to looking at it and I thought, you know, that would be pretty handy to be able to easily sit on here and measure things. I just need to hold it on here somehow. And at first I thought about putting a steel block on here and using the magnet. But then I got to looking at it real close. And this little baby has a slot on the bottom of this that's got some set screws that attach it to the base. Pretty simple. That just goes on there. And I thought, you know, I could get rid of this and take some length off of it and make it a little bit better. And if I mount it like this onto here, I can go anywhere I want to. So that's what I'm going to do. I'm recreating this base in another block. And this will have a hole bored through it and then a cross hole for a nut with probably some plastic in the bore so it won't bar up the stainless steel shafts. These are stainless steel precision shafts I bought to put in there, and they work pretty nice. So that's what we're going to be doing. I got to get the parts ready because I'm going to go over to Don's shop and we're going to do the milling over there, because obviously this one isn't going, and I don't want to take the time to mess with the Bridgeport CNC machine. I'd rather do it by hand. So that's where we're going with that. On to this one. Well, did you ever have a bad day when nothing works right? Well, filming wise, yesterday I filmed the lathe portion of this video and it turned out bad. I had so much light from this little LED work light shining on the workpiece you couldn't even see it. Well, not well enough, but had to imagine what I was doing basically. So I made this piece yesterday and I'm going to go ahead and recreate it today so you can see what the hell's going on. Now, for roughly 8 billion people that have never seen my channel, this is Bob. Bob is a 1973 Chucker Lathe made by a company that I get so many comments on, we're saying it wrong, and then they argue. I just call it Bob. So Bob's got a purpose in life, and that's making small parts very quickly. This is basically what we had before we had CNC machines or numerical machines. My gosh, I remember the first numerical machine I ever saw with the punch tape and all that. I thought, boy, we're doing good. It was antique compared to today's stuff. Anyway, Bob has 8 tool holders mounted on this carousel. You go around like this and select the tool you want. And what that allows you to do is preset all your tools, such as a center drill, you know, a facing tool, a parting tool, a boring tool. Everything can be set up on it. And I have tons and tons and tons of tooling for Bob. Luckily, I purchased all this stuff at the same time when I got Bob. I've got stuff, everything except this. This is all the thread gauges for the automatic threading indexer or threading cutter. But by the time you get all the stuff you need, oh God, tooling's the more expensive part of these machines. just collets. I got 2 drawerfuls down there below this that you can't even see. Anyway, Bob's turned into one of my favorite lathes of all times, mainly because in the old days I would have to sit here and change to a drill, to a center drill, to a reamer, back and forth for every part. This sucker makes it easy. It's got limitations. It doesn't have a tailstock. You cannot come up to your workpiece and have a very long workpiece because you're actually working from the end. You're not working from the side like it would on a regular lathe. If I want to go to the side, I have different holders that will hold a tool bit and mount to the carousel. Well, this one will only go about 1 inch in. So then you got to have, if you want to go any deeper, this one goes about 5 inches along the side. So that's the biggest limitations. But for parts like this, Bob's the cat's meow. With all that being said, let's get to turning. Oh. Before I get started, I've got to do something. Now, you heard me say earlier that I don't really care to open up presents that people send me. In fact, not very many people do. I don't need presents unless it's something really special that I can't find and I'm willing to pay for them even. But there's one video a couple videos ago where I mentioned that I couldn't find a part that Bob truly has set his heart on. Now, I've looked everywhere for a couple years and still do a daily search for it, and I never could find one. A viewer named Russ in New Mexico sent me an email and said, I have that tool. I have no use for it. Would you like to have it? I said, sure, I'll pay you for it. And he said, oh no, it's not worth that much. And he sent it to me. Thank you so much, Russ. I looked for years for this tool. Not for me, but for Bob. Now, I didn't tell Bob that it was coming because I knew he would just sit here and fret over it. Probably get lost in the mail, and then what would I tell Bob? Well, it didn't get lost in the mail. It came. This is a Hartigan C2 tool. It looks simple enough, but it's a very well-made tool height gauge. Now, Bob isn't like your normal lathes that have V-ways or flat ways, well, one on each side that the tailstock and the carriage ride on. Bob has a single bed, I guess you can see it here. It's flat all the way across the top. It's a dovetail bed. It's got a dovetail on either side, and this carriage rides on that. Because it does that, from this area here, this tool sits on top. And this little ring flips out, and you can use it to gauge the tool height. Now, there could be some variations between the tool height and the bed or the center point of the spindle on each lathe they make. So they added an extension down here. I don't know if you can see where it breaks right there. And on the back of it, in there is a set screw. What you do is you set this on the bed, flip this out, and cut a test piece, and I'm going to show you how we're going to do this. And then you use this to adjust it to get a perfect height. Then you put this in your toolbox, and anytime you need to set a tool, it's ready to go. It's the simplest, most easiest way I've ever set tools. There's other ways on a lathe, you know. You can take a 6-inch rule and put it on there and put your tool bit up and go up and down, see which way it flops. That works. I even have one of these. These sits in your spindle, and it's got a little level on top, and you set your tool bit right here and get it level, and you're at the right height. This level and this height here corresponds to the exact center of the shaft. So when this is chucked up, this is the center line of that chuck. It's a cool little tool. I hardly ever use it. Usually I get close enough just eyeballing them. But this one, thanks again, Russ. I'll show you how it works. Now, I went and cut us a fresh piece of stock for today so I can show you from the beginning. I was sitting there editing video last night, which, good God, takes a long time. I always like to spin my stock as I'm putting it in and tighten it down. That way you don't get it cattywampus in there. Now, I don't know where the exact center of that spindle is, but a very easy way to find out is turn something and face off the end of it and see how big of a titty you get on the end. Now, if your tool's set too low or too high, it won't come to exactly the center. And so you watch and you see how far that tool needs to come up to get to the center. Like if you've got a 1/2 inch diameter titty, you would raise your bit up 1/4 inch, half the diameter, because you know your bit's here and you're trying to get it here. It goes up and above the center line. So you'd only take 1/4 or half of the diameter to get to the exact center. Now, kind of cheating a little bit, as I said. I did this yesterday, and I set this tool to the proper height. So when we go and center this, cut and face this off right here, it should go down to an exact point, unless gremlins have got me again. Let's get Bob running here. Well, let's see, that's in second gear. Up here it says it's 800 RPMs at that. Let's see what it does. Now remember, for all you new people, and there's probably about 7.5 billion of people that don't even know what a metal lathe is, as you're turning something round, say this, your bit touches here and then goes into the middle. The speed of this changes how many feet per second as it goes towards the center. Out here you're going much faster than it is when you get into the center. So sometimes if you're having bad finishes and stuff like that, you need to adjust the speed as it goes in. Now Bob can do that very easily on the fly by just flipping a lever and go into second or third gear. So remember that. So I'm just taking a rough speed here and we'll just start off. Come up here and touch off. Now my saw is pretty good. If you're feeding by hand, you can do it this way and vary the speed as you go in. Look at that. Perfect. I'll move this around so you can see it a different way. Go in. As I get towards the center, I'll start going faster. Kind of keep the same cutting speed. Ta-da! Okay. Let's see if I can put the front-facing screen on so I can tell where y'all are looking. Now, as you can tell, I got it really close right there. So now, I use that feature to set the gauge. We know that this is now cutting to the center of that, so we put the old gauge up here, and then we can sit here and flip it around and see if I can feel it. Now I can feel that little bitty burr that's on the edge of that. My wife, I think, shut the door. I can hear her coming in here. Probably wants me to go do a honeydew. Now I'm holding the base down, and that is just touching that little rough spot right there. There we go. I'm happy with that, the way it's set. If I wasn't, I would take and unscrew this a little bit, or screw it in to get it to where it was just right. Now, there's certain things you can't measure by feel. And if I wanted to get really super precision like I did yesterday, I used light to measure the distance between that tool bit and the bottom of that measuring device. Light's used all the time. Back when I used to make a lot of telescope mirrors, you cannot measure a telescope mirror with a dial indicator. I don't care how good it is. You have to use wavelengths of light. And so you could do into the millionths of an inch using a Folcott tester. Well, here I don't have time to go to a millionth of an inch, but I am going to use light. This little flashlight Don gave me years ago. I'm going to shine backlight underneath that lid that swivels in the top of the blade here and see if I can see any cracks. Now y'all probably can't see this, but this is basically what you do. And I go under here and I can tell that that is no light whatsoever coming underneath that tool bit. This isn't rocking unless I rock it. So I know I'm pretty doggone close enough for this. Thanks again, Russ. I'll keep it and use it and pass it on to the next owner, Bob. All right, we've got this one done. Now we need to have about 2 inches of space for our part. And I chucked this in so deep that it's not got 2 inches of space. So what we'll do is move it out. Now for you almost 8 billion people that have never watched, it looks like Bob's rusty. The Bob is not rusty. Bob has a coating of oil over some of these parts that have gotten there over the years and built up a protective layer. Bob uses oil for a coolant. There's a built-in pump and sump down here that I've got a gallon of oil, and when I need it I turn it on, and this is a spigot for it that comes out, and I can direct it onto the workpiece. I don't do it, sometimes it gets smoky in here, but if I need it I've got it. But that's why Bob looks like the way he does. Can't have 8 billion people telling me my machine's running. Now, rusted can we? All right, I've now moved this out. So this may be a little off on his face. So what I'm going to do is take another cut. It doesn't take but a second. That'll true that up for sure. And then I can come down this side. Touch off. And there we go. There we go. Now let's come back out here. Touch off on this side. Make sure everything's locked down. The carriage is locked so it can't rotate. Vibrate, touch off. Carriage isn't locked, the carousel's locked, or the turret. This is actually called a turret. All right, let's take about 10 more thousandths off. Now Bob has an electric drive. It doesn't have a worm-fed drive like most lathes, and it's all controlled from over here. Clutch, like on most lathes, is down here. We're going to take a little cleanup cut and see if our speeds are about right, what kind of finish we get. Hope y'all can see that today. Yesterday's video was so dadgum and washed out. Now watch this space right here. That's where I'm watching, plus the chuck. As I said, you work all your material from the end. I stopped it there. That's as far as this tool holder can go down the side of the workpiece. Like I said, if I need to get more, I'd put a longer tool holder. I think 5 inches is the longest I have. All right. See how it got some over there, but not over here? So we're going to go back out. We're going to go down and take about 20 thousandths of an inch off. Now this outside dimension is not critical. That's good. Nice finish. Okay. I've got this ready to go. I've got this ready to go. So the only operation I need to do now is put a chamfer on this edge. Now Bob, like my Axelsons, is able to cut a chamfer by using both clutches at the same time. You got to set it up right so that the carriage goes this way and the feed goes in this way. So, and I know on Bob, I got to set this switch to right. And when I do that, the carriage will move to the right. And let's turn that off. this will feed in. Always check it. Now my Axelsons, I can adjust this to where it can be just opposite. But on Bob, I don't have that adjustment, or at least not that I've found. So now I'm going to come in and I'm going to touch off about a 32nd of an inch, maybe a 16th right in here. And then I'm going to pull both handles at the same time on the clutches. 1, 2, 3. Now I always do this twice. The reason being, you don't want to take such a huge cut the very first time. Because as it's going in and traveling out, the material it removes is much greater as it goes. So I'm kind of knocking off that little corner so that when it cuts the next time, it's kind of taking an even amount of material. There we go. Right there. All right, 1, 2, 3. Now that left a very nice little 45-degree chamfer. I'm going to take a little file and break that edge a little bit, and this top edge. This side's through. Now that we've got this one ready, I'm going to turn it around and I'll do all the other operations from this side. Now this is kind of tricky in that I need to leave 2 inches out so I can cut it off a little bit less than 2 inches. That'll be about right there. I don't want this to be so tight it leaves huge ugly marks on it, but it's got to hold it. You don't want it flying around. Okay. Now I've got all this material here that I need to get rid of. And to do that, I'm going to swing into view here for you. I've got a parting tool right here. And as I'm looking at it, it doesn't look square to Bob. Just as a rough way of looking at it. Let's put this on Bob. Guess it's my eyeballs, because that looks pretty good to me. All right. Never mind. Now, this tool needs to come in here, and I'll line my cut up with this. Now, I want it to be a little bit less than 2 inches. Because the width of the body of the T plate is 2 inches, and I want it to tuck underneath it a little bit. So we're going to start with a parting cut right here, and then we can face it off to the length we want. Now, I've had people tell me that parting is one of the hardest things they've ever done on a lathe. I had one friend a long time ago that was just amazed that I could even part off on the machine. Secret is making sure your cutter is on center or just a tiny bit below. And speeds and feeds is the biggest thing. You just can't go too fast. Lubrication and an easy handle here. Once you get it going and get everything set, you could flip the clutch and do it by power. But for this one, I'm just going to start off by hand. Okay, I've gone down into first gear, which on Bob says it's 270 RPMs. Put it in forward. Got the carriage locked, tool bits in tight. Got a little bit of my favorite Cat Magic aluminum cutter. Put a little more juice on it. My wife can't stand the smell of this. I love it. I don't know why she don't like it. Heck, it's cheaper than aftershave. Well, not really, but you don't need aftershave if you put this stuff working all day. Now this little cutter is not going to go all the way to the center. That's okay. I can get it finished off very quickly with a hand tool, and I won't have to change bits again. Listen to the work. Listen to how it's cutting. When you hear it start kind of growling a little bit more, put some more fluid on it. And I'm getting this cleaned off so I can see the side of that bit. I don't want to bury it. Can't see, clean it off. Getting close. That's close enough. I don't need to ram it in there. All right. Get your handy dandy hacksaw out. Can't get a very big stroke on it, but this is aluminum. It won't take long to. Ta-da! Now, thanks to the beauty of Bob, all I got to do is flip this around, lock it in place, roll around, and we're going to face all that off. I'm going to go back up into second gear. Now we'll measure. I wonder where my little 6-inch hook router went. That's good for these things. You can just grab it and do it. Now that is almost perfect. So almost a 1/16 off the end of what I want. That'll look good. Okay. Now back to the one last thing we need to do is break this edge over with the chamfer. Same procedure as before. Going in here about a 1/16 of an inch, right there. Start your rotations. Make sure it's in the right direction. Pull both levers at the same time. 1, 2, 3. Reverse. Come back in. And now I'm kind of looking down through the vise and seeing the chamfer on the finished end on the other side, and kind of going to see if I can make them really, really close to the same. About right there. Okay, 1, 2, 3. Take it out of gear, roll it out of the way, get your tiny little file. Being careful that you don't hit a chuck with a file. You will have a bad day. Okay. How's that look, sports fans? About even? Yeah. Okay. Now we switch to the other part. We got to bore a hole through there and ream it. Bob doesn't have a tailstock, so I don't have something that is automatically telling me where the center of the spindle is in the workpiece. I've had to go through a procedure of I put a collet in and put a bar in, and I put the 3/4 inch bar in the collet, came here, put a tool block on, and then I adjusted this tool block to fit onto that bar. And when I did that, I came back over here and I set this stop. So now, whenever I roll this back and hit that stop, I know that the center of this tool block is the center of the spindle. That's the way you have to do it on Bob. Now I can roll into Bob to the face right there. Start a nice little hole. Now, remember I said in the center you don't go as fast as you do on the outer edges? I'm going to switch Bob into 3rd gear. And Bob, you can switch as it's still turning. Cool, huh? Let's get a center hole. I don't know if you guys saw that, but when I started pushing, this slipped into the chuck a little bit more. I saw it happening, so I didn't push harder. Now, I'm going to tighten that up a little bit. One of the reasons it is because this big old center drill is kind of dull and big and broad out on the end. If I'd used a smaller one like that, that wouldn't have happened. But this was what was in the machine, so that's what I used. So let's see about. Now we're going to have to change tools here. Yesterday for doing this, I took this and put, my ductboards need to be wider before I kill myself. I took out my keyless chuck, but because it's still on the center line, I can put it right back in. I don't have to worry about lining everything back up. So let's get a big deeper hole in there for this. There we go. And I'm going to kind of go up through the drills because I don't have it so tight in the chuck, so I don't have huge marks on it. We're going to step it up with some different size drills. Put a little bit of this on there. Remember, you need to be at a higher speed for the smaller drills. Kind of pecking it as I go. Clean out the flutes a little bit. I want it to drill straight through there. If you were to force this little thin bit through there, you can make it go off center. So don't let it get bound up with all the junk on the end. It's trying to weld itself. A little bit of fluid helps keep that from happening. And we'll go all the way through. Let's go on up to a different drill and I'll show you something else. If you notice, I'm at the end of my flutes on this drill. Don't go in there. You can keep drilling, but you have to be careful that you don't pack up your chips in those flutes. See how they pack up on you? Make sure you clean them out. Okay, we're all the way through. I need to ream this 625. I need to drill a hole that is basically one size smaller than that for my reamer to go through. Most of my reamers, when you get into the big side like this, they take a weird size bit. Like this is a 39/64. Well, this is a 625 reamer. This is the proper size to drill this hole for reaming. I always tape them together, rubber band them together, because you know, you'll grab that and use it for some off-the-wall thing real quick, and then you won't have the proper one you need. They're cheap in the long run. Just keep them together. Now, a problem I have is this won't fit into this chuck. It's sad, but it won't. And as that right now is one of two that I have set up for center, this one over here is a 1/2 inch. This is a 3/4 inch. My shank will fit into it, see here? But my reamer won't. My reamer has a 5/8 shank. I've got a 3/4 set up in here, so I'll show you how I get around that in a minute. But for the 1/2 inch, we're going to swing around to the toolbox I have already set up. Put that in that holder. tighten down. A little fluid in the hole this time. Now, I have it in third gear, which was 1250 RPMs. Because this is a bigger drill bit, I'm going to slow it down. I'm going to second gear. Let's see how it cuts there. I think that's a little fast. So we're going to go into first gear. And that's stuck up on it. So let's tighten that down a little bit more. And I want it to go a little bit faster than that too. With the dial up here, I can adjust the speed. It sounds kind of rough. A little more fluid in it. Just like cooling fluid or cutting fluid, it helps lubricate. And it makes your chips come out a lot easier, not stick to your bit. All right, go back down to my standard speed there. But now I've done this operation. I'll take this out. Clean it off, put it back in its holder so it's ready to go the next time I need it, and I don't have to look around for 4 days. The reamer. As I said, it's a special problem. I don't have a tool holder for this size. So, what I have done made a collet for it. Let me see if I can find it. A collet somewhere, I know. Where did my collet go? Just used it yesterday. Tiny little thing. I hope I didn't throw it away. There it is, right there. It'll bite me. Bob is good at making small precision things. Well, I made this collet really quickly. This collet, or spacer, whatever you want to call it, fits over my shank. And then it will fit in this 3/4 inch tool holder. Now, I don't need this all the way out for this project. The farther it is, the more air it can have. So I'm running it out to right there. And I don't ever tighten down on the inside of this collet because it'll, I do it back here where there's collet's not touching. I don't want it to form this. I can't, it's so thin I can't cut a slot on it. Okay. Let's lube up the tool. Second gear forward. running this in through there a couple of times because I don't really matter if it's a little bit oversized. Sort of slide on that stainless steel precision shaft good. It can be a little loose. This isn't precision. All right. So that's reamed. What I'd like to do is put a little chamfer on the inside of this, just because you're going to put a shaft in there, and even though the shaft's got a bevel on it, it'll be nicer if this does too. So I'm just going to put it in here and do it lightly. Get Bob out of the way here. Need to find some cork to make Bob a new brake pad. It works, but not very well. And now that Bob's makers filed for Chapter 11, it's going to be hard to get parts for Bob. See how simple that is? Let's take it over there and see that it fits. Decided to bring the mountain over here instead of taking the part to the mountain. Let's take this side off. Nice. Well, we're one step closer to finishing this Kingway tool. What I'm going to do now is take this over to Don's, put it on his mill, and flatten an inch and 1.31 inch flat wide here. Then bore a couple of holes here for some set screws with a little brass plug to keep from marring the surface. Then that will lock on, and then the plate that holds the level vials will sit here. Ought to be nice. Might make this a standalone video depending on how long it is. Thanks for watching.